important things here and give you one place that you can look, especially given that we have a Monday test. So Monday morning, if you need to pull out something and kind of refresh your memory, I've tried to organize everything with you. The first thing we did in this was the velocities, okay? And so you need to know the difference between average and instantaneous. So I have on there, average velocity is just the slope between two ordered pairs. And we know slope is y2 minus y1 over x2 minus x1. Instantaneous is when you look at all of your average velocities and see what they approach. So this is when we have the tables. And we usually have like an x, a y, and an m. And this value that m is approaching gives you your instantaneous velocity. So it's like taking all of those average velocities and looking at what value they are going to. You guys okay with that? Then we went into continuity. We know that if we break one of the rules of continuity, we have a discontinuity at that given x value. If I'm asking you where something is continuous, I might say, which rule is broken? So you have to tell me one of these three rules, not just there's a break in the graph. Tell me based on these things. So the first one, the function must exist. So a situation where your function doesn't exist might be like, here's some graph with an open circle. Let's say that's at 2. So this is discontinuous at x equals 2. The reason being f of 2 does not exist. It's an open circle on my graph. There is no point. Mm-hmm. Second rule, the limit has to exist. So a situation where maybe the limit doesn't exist might be when we have a break in our graph like this. So if I look, this one is discontinuous at x equals 1. The reason the limit does not exist at 1. And the third, the function has to equal the limit. So if I gave you a graph, say I have this, so does the limit exist? Yes. If I put another point down here, does the function exist? Yes, but they're two different numbers. So this one is discontinuous at x equals -1. The reason f of -1 does not equal the limit at -1. They're two different values. So if I ask for a rule, what rule is broken? You have to tell me one of these three things. The function doesn't exist, the limit doesn't exist, or they are not equal. Are we okay with that? Next thing we talked about was discontinuity. So we know those are the rules for continuity, but I might say, okay, this graph is discontinuous. Tell me which type it was. So an infinite discontinuity. If you're looking at a graph, what does that mean? A vertical asymptote. So you have something like this. If you're looking at an equation, how do you know? If the bottom equals 0. So both of these would be an infinite discontinuity at 1. So it's places where you get a vertical asymptote. Either that means on the graph you see it, or we know in a fraction at the bottom is 0. That's when it happens. A jump discontinuity is usually the result of what? What does it look like on a graph? Like when you have two pieces of the graph and they don't match up. What does it look like on when you're looking at the equation? Greatest integer would be 1. More often we see just any kind of piecewise function where maybe it's so piecewise, where the pieces go from one inequality to the next. So jump are typically piecewise functions where you jump between the pieces. Removable. Didn't leave myself much space there. On a graph, what does that look like? With an open circle that may or may not have another point somewhere else. From the equation, that happens when you have something that cancels out, or we could see it in a piecewise function where one piece is not equal to and another piece is equal to. And both of those, the removable is just a hole in the graph. So do we know what the three types look like, either from an equation or from looking at a graph? Okay. Limits. We have several different things there. The formal definition, I have already told you. Not tried to hide that at all. I'm not going to make you do one on the test, but you know, I usually put some multiple choice questions on there, or sometimes I do. I might put one like, which of these is the definition, so you should be able to recognize it at least. And then of course, if you want extra credit, you should know how to do one. So the formal definition says if the absolute value of x minus a is less than delta, then the absolute value of f of x minus l is less than epsilon. So at the very least, you might need to know that, maybe not be able to write it all out, but maybe pick it out of a multiple choice question. And then, you know, to actually do it, you have to write out your goal. Then step 1 is find your delta, and step 2 is your proof. When we do limits at a number, our ultimate goal is just to be able to plug in the number, right? But we have to solve any problems to get there. So first, always check to see if you can plug it in. If you can't, try to factor and reduce. If we have radicals, try multiplying by the conjugate. Sometimes none of those things work and you just have to think through it. And we had a few of those on the study guide that we'll talk about. Limits at infinity, our goal is just to be able to plug it in, but we can't if you have like infinity divided by infinity or infinity minus infinity. So we might have to do some other stuff first. So that's when we divide top and bottom by the highest power of x. You might still have to multiply by the conjugate. You might still need to factor and use reasoning. All right. Asymptotes are x equals a number, and you just look at it, whatever makes the bottom 0. Horizontal is y equals a number. You have to do both the limit as you approach positive infinity and the limit as you approach negative infinity. And I will be checking that you did both. We know most of the time they will be the same, but we have done examples where they are not. So you do have to check both options. All right, and then let's just kind of reason through a couple of these before we start talking about our study guide. So anytime you have 1 over infinity, what does that go to? 1 over a negative infinity. 0. It doesn't matter if you're going positive or negative infinity. All right, let's think about, I have a typo. Let's make one of these a left. I didn't mean for both of those to be a right. Sorry. Okay. If we have a number over 0, we know that's a vertical asymptote on our graph. That means it's either going to a positive or a negative infinity. So if you have a positive divided by a positive, it's going to positive infinity. If you have a positive number divided by a negative number, negative infinity. All right, if you have a really big number times a really big negative number. If you have a really big number, minus 1. Still a really big number. All right. So this is kind of your summary. Look it over before you come in here Monday. Okay? Any questions about that stuff? Then let's talk about study guides. Do we just want to try to work through as much as possible? What do you guys want?
Oh, wait,
Certain numbers.
is there extra study guides in the thing?
There might be an extra copy over there. So for number 1, we already kind of talked about on that summary sheet. Average velocity is just slope between 2 points. Instantaneous is what those slopes are approaching. So from the table of values. A limit is basically as you're getting closer to x, what's your y approaching? The actual formal definition, I put it on the study guide, I put it on the summary sheet. The limit is x approaches a, f of x minus L, okay, that's or equals L. So that means if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. So that formal definition box on there. To be continuous, again, the 3 things. The function exists, the limit exists, they're equal. Do we need to talk about the graph on number 4? I feel like we've had trouble with those a little bit. Let's look at that. I would start with the easiest things, which are the points at the end. F of 0 equals negative 1. So that means 0, negative 1 is a point. F of 3 equals 1. So 3, 1 is a point. All right, if I'm just working backwards, the limit as we approach 3 from the right is 2. Now I can't have another closed circle at 2 because it's function, so it has to be coming into an open circle. So as I'm coming in from the right, it's going to 2. Okay, it doesn't really matter what this line looks like, it's just approaching it. The next one said the limit as we approach 3 from the left was negative 2. So again, I can't have another closed circle, but as I'm coming in from this side, it has to be going to negative 2. Okay, and I don't really know what this graph is doing yet, except it's going there. The final condition was as we approach 0, so that means from both sides, it has to equal 1. Can I have a closed circle there? Nope, because we already have a closed circle, so then we just have to match these up, and this has to be from both sides, so something on the other side. Doesn't really matter what. So several different options there. The things that you have to have those open and closed circles in the right spots. All right, number 5. Let me just read off the answers there, and you guys tell me which ones you want. Let's look at these.
Can we also look at E?
Yep.
I'm very sorry.
Wait, did you say it was 3.5 or 3 over
3
5?
halves. Did I not say 3 halves?
I thought you did.
Okay. So we have the limit, we approach negative 3. So first thing you always see, can we just plug this in? No, it gives us a 0 on the bottom. So we are factoring, and you are good little children writing your limit on every step up until the point where you plug it in. Of course, yeah. Okay, what happens here? Those cancel. So can I plug in my negative 3 now? Yes, because we're no longer getting 0 on the bottom. So we have negative 3 minus 3 over negative 3 minus 1. My limit went away because I plugged it in. So that gives me a negative 6 over a negative 4, which is a positive 3 halves. Since I'm here and I've already worked out this one, can I look at B real quick? it's the same problem, but we're approaching a different x value. So you still factor and you get to this point. But did it get rid of my problem? No. However, on the top, if I put in 1, 1 minus 3 is negative 2. On the bottom, if you put in 1, you're getting 0, but we're putting in something bigger than 1. So we're approaching 0 from the right. If we're getting 0 on the bottom, we know it's a vertical asymptote. So if you have, we know it'll either be positive infinity or negative infinity, because we have an asymptote. So if you have a negative over a positive, it would be negative infinity.
Will it always be positive or negative infinity?
As long as you factored and reduced first.
Okay.
Yes. And as long as it's a one-sided limit, not necessarily the two-sided. Okay, C, we have a limit as x approaches 3, square root of x plus 6 minus x over, can I go ahead and factor out an x squared on that? X squared, x minus 3. Just save myself that's writing here. Okay, can I plug in my 3? No. Getting 0 on the bottom. So what is our option with radicals? Anytime we have a radical, we multiply by conjugate. So if I do that, we have the limit as we approach 3. Radical x plus 6 times radical x plus 6 just gives us x plus 6. Outside and inside cancel, so minus x. On the bottom I have an x squared, I have x minus, yes, x squared, thank you. X minus 3, and the radical x plus 6 plus x. Okay, have I gotten rid of my problem yet? No. But on the top, if you take out a negative, then you have x squared minus x minus 6. And what can we do with that? So multiply negative 6, add negative 1 will be a negative 3 and a positive 2. So now the x minus 3 is canceled, and that's what was causing my problem. So now we can plug in. So we get negative 5 over 9 times the square root of 9, which is 3, plus 3 is 6. So negative 5 over 50. So when you have radicals, try conjugate. Remember, just trying to plug in the number and reason through it, that's the last resort. And that only works if you've factored out and canceled everything that will. Okay, so we have to try that option. Let's look at E. So we have the limit as we approach negative 4 from the right of x plus 1. I'm going to go ahead and factor out an x on the bottom, so x plus 4. So we factor. Can I just plug in? No. Can I reduce anything? No. Do we have any other tricks for this? No. So we have to reason through it. And this is a one-sided limit, so we can. So if I put in negative 4 on top, negative 4 plus 1 is negative 3. On the bottom, this x would just be a negative 4 times negative 4 plus 4 is going to 0. But since you're putting in something bigger than 4, are you getting a positive or a negative? A positive. Okay, so the bottom is going to 0. And we know anytime we're getting 0 on the bottom, we have what? Vertical asymptote. So our answer is either positive infinity or negative infinity. Okay, let's think about this. On the bottom, if you have a negative times a positive, you're getting a negative. And the top is negative. A negative divided by a negative is so positive infinity is our answer. So if I just try to plug this in, I get infinity plus negative infinity, and I can't do that. But if we factor, what can we take out? And that leaves us with a 1 plus x. if you have a negative infinity to the fourth, and then 1 plus negative infinity. So a negative to the fourth is positive. 1 plus a really big negative number is negative. And a positive times a negative is negative infinity. Is that one okay? Alright. Let's look at H. We've had several of these and they seem to cause some problems. So if we need another one after this, I can make up another one to do. So we had x minus the square root of x squared plus 4x plus 1. We're doing the limit as we approach infinity. Can we just plug the infinities in here? No. Then we get infinity minus infinity, and we cannot do that. Anytime we have radicals, what's our strategy? Multiply by the conjugate. On the paper I handed back, you have to be careful. Some people did it like this, but that's changing the problem. You can only multiply something if you're multiplying by 1. So we have to think of this as over 1 and do it on top and bottom, so it would cancel itself out. So, in the limit as we approach infinity, if I multiply those, we get x squared, outside and inside drop, minus the x squared plus 4x plus 1. Notice I'm putting that in parentheses, because what do we have to do? Distribute that negative. If I do that, and then the limit as we approach infinity, x squared negative x squared drops, and then 4x minus 1 for x plus this. And then, anytime we have these fractions, what do we do? Okay, so I have a square root of x squared, which is the same thing as 1 over x. So you can do 1 over x if it's not in a radical, 1 over the square root of x squared if it is. So I get negative 4 minus 1 over x. Sounds like a leak to me.
Oh, I thought that was you.
No. Okay. So this x is not under a radical, so we're going to multiply by 1 over x, and that gets stripped on, let me know. This one is in the radical, so we get 1 plus 4 over x plus 1 over x squared. Then a number over infinity goes to 0, so we have negative 4 over 1 plus square root of 1, and all these would be zeros. So we get negative 4 over 2 and negative 2. I think it's stopped.
You're silly, just.
Yeah, just waiting for it. If we have time at the end of class, I might do another one of these radical questions, because I think we've had some issues with those. Let's check the next little part. I know we want to go over for instantaneous when t approaches 1. So what you're going to do is make your table. Your t value should be getting closer to 1, so you could do 0.9, 0.99, 0.999, and you could do one bigger. So 1.1, 1.01, 1.001. So to get your s, you're putting them in the equation. And to get the slope, you are going to do the 0.1, 3.25, and each of these points. Okay, when you plug those in, you're just trying to tell me what this is approaching, and both of those should give you a 2.5. So it's 2.5 meters per second. Obviously, without a calculator, you really won't be able to make one of these tables on the test. So I might ask you to find an average velocity of something, a slope with some easy numbers, And I might give you a table and say, tell me what the instantaneous is. So knowing that from the table, instantaneous is what value we're approaching. Yes?
So we plug like 0.9 and 0.99 into the equation that was given?
Yes. To get your essentially y value.
And then how would we get our slope?
You do, so like if you put in 0.9, you get 3.0025. So you do y2 minus y1 over x2 minus x1. You're just doing the slope formulas, just like we did here, but you're doing it on every one of these. Number 10 is discontinuous at -4 because the limit does not exist, and at +2 because the function does not exist. Are we okay with that? 12, I'm going to save that one. If we have time, we'll go over it, but we know we've seen some of those. 13, so you have to show me some work on this. Vertical asymptote, you can just look at the equation. What makes the bottom 0? -3. For the horizontal asymptote, you have to do the limit as we approach infinity. And the limit as you approach negative infinity. And I'm checking that you do both. So you're going to work them out essentially the same. You'll do multiply by 1 over x, top and bottom for both, and work that out, and you should get -1 both times. So your horizontal asymptote will be y equals -1. Is that okay? Alright, so we're hitting 14 for sure, maybe 12, and maybe one more radical problem. Is there anything else that I have not covered that you guys need? So, we are trying to find A and B to make this piecewise function continuous. The only way a piecewise function is continuous is when you're graphing and you go from one piece to the next, what happens? What has to happen for those pieces to make a continuous function? They have to match up, right? So, if I'm looking at this, we have an x squared minus 4 over x minus 2, if x is less than 2. And it's equal to a times x when x equals 2. So if it's continuous, these have to be the same when x is equal to 2. So let's see, what would I do on the first one? But I can't because it's undefined, so we factor. So the first one reduces to x plus 2. And the second one is ax. I need those to be the same when x equals 2. So if you plug in a 2 for your x, you get 4 equals 2a. So a has to be 2 to make that piece continuous. So then for b, we can do a couple different options. You can look at when x is 2, it has to be the same as the ax, or when x is 3, it has to be the same as the bottom one. It doesn't really matter, it will give us the same answer either way. So, if I did this one, so we know ax when x is 2, and then we're going to jump to this piece. So I would need those to match up. So I need ax to equal this when my x is 2. But I already know a is what? 2. And if I plug in the 2 for x, I get 4 equals 7 minus 2b. So subtract the 7 and divide, and we get 3x. going to put a problem up here that is not on your study guide. So another one of those radical problems we've had trouble with. I said a limit, we approach infinity. Square root of x squared plus 5x minus the square root of x squared plus x. Okay, can I just plug in my infinity right now? Why not? Yeah, infinity minus infinity, that doesn't work. So what is our strategy? Conjugate. So I'm going to say this is over 1. I'm going to multiply by the square root of x squared plus 5x plus the square root of x squared plus x. Question. So when I multiply these and I FOIL, when you take two square roots times each other, what happens? So I just get x squared plus 5x. Because they're conjugates, we know outside and inside cancels. Minus the x squared plus x. What do we have to do here? We'll always have a negative here, so we have to distribute. So we get the limit, we approach infinity. X squared and a of x squared cancel. 5x minus x is 4x over this. What is the highest power of x that we see? We have an x squared under a square root, and the square root of x squared is the same as x. So 4x over x is 4 over the square root. X squared over x squared is 1. 5x over x squared would be 5 over x. X squared over x squared is 1, is 1 over x. So if you plug in your infinities, we know a number over infinity goes to 0. Square root of 1 plus the square root of 1 will just be 2. And we get 2 for the final answer. What do you guys want me to look at now? Do we want to do number 12 then, if we have time? Alright, so we want to prove the limit. So the goal, formal definition, if the absolute value of x minus a, my a is 10, is less than delta, then the absolute value of f of x, so that's the function, minus the limit, so minus negative 5 would be plus 5, is less than epsilon. So first, we have to find delta. And we do that by starting with our epsilon statement. So if we combine like terms, we have a negative 4/5 x plus 8 is less than epsilon. What can I need it to be an x minus 10, so I have to factor out that coefficient of x. So I have to pull out a negative 4/5. And 8 divided by negative 4/5 would be a negative 10. But when you bring a negative 4/5, when you do the absolute value, you get positive 4/5. And then to move it to the other side, you multiply by the reciprocal. So we have the absolute value of x minus 10 is less than 5 epsilon over 4. That's step 1. Step 2 is the proof. And we go back to that goal and we state everything except the less than epsilon. So if the absolute value, oh, hold on. Before I state my goal, what do I need to say? Mm-hmm. So if the absolute value of x minus 10 is less than delta, then the absolute value 3 minus 4/5 x plus 5. I can't say the less than epsilon now. I'm working it out until I get those things. So if I combine like terms, we're just repeating what we did before. And we know we could take out that negative 4/5. But the absolute value of a negative is a positive. But we know x minus 10 is less than delta, so this is less than 4/5 delta. So I got my less than. And then we know that delta is, and that gives me my epsilon. Why don't we look at, do you guys want to look at number 8 real quick? We've got about 5 minutes. I know that was another one, I gave you the answers, and I think it was reasonably okay, but maybe wouldn't hurt to check out if we have time. Okay, make sure you know how to graph piecewise functions. We did it in our review unit, and we're using that skill now, so you can probably expect to have to graph one on your test. And so you're really just making a t-chart for each piece, but you have to start with the condition. So I have to put in a 0. Square root of 0 is 0 because it didn't have an equal to, that would be open. Then you have to put in things less than 0. So if I put in a negative 1, that gives me the square root of 1, which is 1. If I put in a negative 4, square root of would become a positive, and we would get 2. So this piece looks like that. Second piece, we have to put in 0. It's an equal to, so it'll be closed. So 3 minus 0 is 3. Put in a 1, 3 minus 1 is 2. Put in a 2, 1. Put in a 3, 3 minus 3 is 0, but that did not have an equal to, so that's open. Last one, we have to put in 3. It would also be open, so 3 minus 3 squared. 0 squared is still 0. If I put in a 4, we get 1 squared, which is 1. You put in a 5, get 4. So we're getting a part of a parabola here. So then you can go through the pieces. Where is it discontinuous? At 0, because why? The limit does not exist. And it's also discontinuous at 3 because the function doesn't exist. All right, so B, the limit as you approach from the right. So as I'm coming into 0 from the right, what y value are we getting close to? 3. B, as you are approaching 0 from the left. So I'm coming in on this side, and this time it's going to 0. So the overall limit, if the left and right don't match, it does not exist. E, as you're approaching 3 from the left, so smaller than 3, we're coming in here, it's going to 0. F, as I'm coming into 3 from the right, it's going to 0. And so then the overall limit is also 0 because those pieces match